Hello everybody, Thy Lord Root here, and welcome back to my KSP tutorial series. Today we're going to be focusing largely on getting into orbit, which we've already done, but doing useful things in orbit as well. And so, I thought we'd start out by creating a new craft for this. Now I'm going to start with the Mark 1 command pod for this, as you might expect. And we're going to grab ourselves a little decoupler and stick it on the bottom. You probably remember a lot of this from last time. We're going to take a fuel tank and an LV909 and stick it down here, and that will help us a great deal. Although there's other ways we could really go about this as well. These monopropellant engines, they have a lower ISP, but they could be very useful for some applications, because it means you don't have to carry extra monopropellant. And I guess really I should go into what monopropellant is and why you might want it. Well, monopropellant is basically the fuel that you'd be using with, if I can just find it real quick, I think it's under control. You'd be using with these guys right here, these thruster blocks. And basically this allows for finer control of your vessel. I'm going to put 4 of these on, and if I put it around the center of mass, then what will essentially happen is that we will end up in the situation where the craft won't rotate. And that's going to be good, otherwise we'd have to have 2 sets to compensate for that. There is also this ASAS, or this Advanced Inline Stabilizer. These are reaction wheels. You have one inside of your command pod and inside of most probes. Now, in the past, way back in the past, I mean probably before 0.22, maybe even 0.21, these guys actually gave you stability control, which we now get from our pilots. But now what they are these dills that provide reaction control. And so basically, if you're having trouble turning your craft, you can do it in one of 2 ways. You can either go here to the fuel tanks, you can grab yourself some of these monopropellant tanks, and you might stick them on the side here if you want. You don't really need very many of them. And what I'm going to do is I'm just going to hit shift and then S and turn these down like this so that they're flush with it, or almost flush. We can do some really cool things with that, like for instance, I mean that does look pretty tight, but we could actually go to the offset and make this look a little bit better. Maybe something like that. You still want them to be accessible, of course, for refueling purposes. But that's looking pretty nice in my opinion. At any rate, when we drain the sky, that center of mass is going to shift, and putting those monopropellant tanks down there does help with that, because one of the things you might notice about fuel flow when you play is that fuel always drains downwards, so eventually what will happen is your center of mass will move up, which is not always so good. It makes designing planes a little difficult. But we're not designing planes right now, so let's talk about what else we need to be in space. One thing we do not need is we do not need any provision for life support. And that's because Kerbals, for some reason or another, can stay on life support indefinitely. maybe there are plants which would explain possibly why they're green. Oh, that there's actually an interesting point of contention there. You can imagine that in a system where most of the light available is maybe, I don't know, maybe red, or even where there's very little light available, you might have black plants because they might absorb they'd be trying to absorb everything they could. At any rate, we got these solar panels, which you may remember from last time. They are essentially there for us to be able to go on and recharge our power when necessary. Another thing we could use to recharge power, but which does have a little bit of mass and doesn't recharge it all that quickly, is this thermoelectric generator. Now, the deal with this radioisotope generator is that these actually exist in real life. They're not a work of fiction. What they are basically these little collections of radioactive material that run over something called a thermocouple, which is a junction between wires of two different metals. And whenever you have a temperature difference, it generates a current, and so you can get electricity out of it. But we're not going to do that. We're going to look instead at these photovoltaic panels. There are two versions of these. One's with the little casings on them, and one's without. The ones without, as it turns out, are not... they're a little bit lighter, so it depends on how you want your craft to look. That is one way to think about it. I'm just going to sink real quick these batteries inside the hole. Like that. So that they're nice and out of the way. And that is somewhat of an expensive craft, but we're in sandbox mode, so it doesn't really matter. Let us also... well, let's save this real quick before we do anything. Call this Orbiter 1. This is just the Orbiter. Now, where was I going to say? Oh yes, there are also other things like these lights, which may or may not be useful to you. They're good for space when you're being eclipsed by the planet and can't see the sun, but I don't think we'll put any on. And then there are landing legs. I might save that until we go to our first celestial body that's not Kerbin. So before we move on, what I want to do now is I want to set these solar panels to an action group. And I'm going to set them to custom 1, which means you hit the 1 key on your keyboard in order to toggle them. You don't want them deployed the entire time, because if they are deployed the entire time, then you're going to run into this issue to where you're not going to be able to, they'll basically break off of the atmosphere. Now let's look at another rocket design. We had created a single stage rocket. Well, relative to the payload, you see this guy here is our payload, and we want to get this guy up into orbit. This is a design I came up with a very long time ago, to where what we can do is we can create something that sort of resembles the Delta Heavy. And so the way we're going to approach this is from the standpoint that we know that this guy here, I'm going to put another fuel tank on it, a bit of a larger one. This one core here is it's got a limited duration. We pretty much know from the last time that that one core is not going to do it. We also know that we have an engine here that has a somewhat limited thrust, but at the same time we have a gimbaling on it that we can use to control everything. Well, that is all well and good, but what I'd like to do now is I would like to duplicate this, and the way I'm doing this is hitting Alt and then clicking on the part that is the root part for this. And now I am going to go through and I'm going to attach these guys up here. And let's just take this offset deal and get these guys nice and flush like that. Well, that's kind of weird. It's... oh, well, yeah, no wonder. Let's try this again. Actually, you know what? We can do Control-Z there. So let's again grab this part and move it up just a shade. And we'll grab these radial decouplers as well and move them up as just a little bit. Now for some reason it's decided to embed everything inside. Not quite sure why. But at any rate, we now have a decent craft with a couple of things missing. The first being that there's really no reason for us to carry these gimbaling engines, because we have engines that have a lot more thrust, and we have that gimbaling engine in the center there. So we're going to do something called fuel crossfeed. And the idea behind fuel crossfeed, if I can find it, I guess it's here, is that these guys are feeding into each other, into the center tank, and the center tank is full by the time we drain these two tanks. So that's something that's very nifty. I'll just call this guy OS1. Now, as it turns out, you don't actually need these monopropellant tanks per se. You get 10 units of monopropellant whenever you put down a capsule, or thereabout. But they're good to have. So let's just take this thing and launch it real quick. Oh, we forgot to arrange staging too. We will just do that at the launch pad. I believe it's this guy here. There we go. So SAS is on. The thrust to weight ratio is probably going to be ridiculous on this. But we have plenty of fuel. And as you can see, these tanks here are not draining at all. This guy, however, is, because it's at the top, it's running out of fuel first. And we can expect to see these guys drop off probably somewhere around 10 kilometers. They are getting us out of the atmosphere pretty quickly. I'm just going to throttle back real quick so that we do not exceed terminal velocity. But you will see from this that while the rocket is a little bit more expensive, we will have more thrust-to-weight ratio than we would otherwise normally have. And you could probably even make this thing a little bit smaller. I probably overbuilt this a little bit, because the maximum thrust of this is a little bit higher than that 200. It's actually closer to, I believe, 630. So including this launcher, we could, in principle, get about 63 tons into orbit. That almost doesn't seem right, but, well, the trouble is going to be that, of course, when these guys run out of fuel, these engines, that they will lose these engines as well when we stage. And we will have a thrust-to-weight ratio that's less than Unity. That's something to consider whenever you're designing these guys. I'm going to go ahead and begin my pitch program here. And I am going to bring this guy over very slightly. That's main engine cutoff right there. And that is something we do want to be careful about. We were lucky there. You see, we could have put the Separatrons on there, and that would have helped a great deal. And those guys, of course, exploded underneath us. Let's see what our time to apoapsis is like. I'm going to begin bringing the sky down. Again, you want to be under 2 minutes. Closer to between a minute and 47 or 48 seconds is probably better. But yeah, we will get this guy lined up. We're losing altitude, so I'm going to pitch up just a little bit. And as we're flattening out, I mean, at this time, we're now gaining time to apoapsis, but this is acceptable. So I think maybe something kind of like that. I'm going to try and raise our apsis just a little bit. I'm going to do that by pointing downwards, basically inducing a rotational component. So I think we judged this about right. I'm just going to use this stage here to raise our apsis just a little bit more until we get to staging. And I think That'll be okay for now. It was a little inefficient to do it this way. And we will pass through periapsis very slightly. Part of what happened here is that we well, might help if we actually turn on our engines. Let's spread this guy out. As you can see, we almost got a full tank here. And we're going to lose a little bit of this to drag. Once we get out of this regime here, then we will do okay. That's in 13 minutes. We just need to, really once we get above this dark blue area here, we will be fine. And I was being a little bit optimistic here, I reckon. I did waste a little bit of fuel because of the way that I handled this. I lowered my periapsis while I was to where I was at, so it did slow me down quite a fair deal. But anyway, while we're here, why don't we hit one and deploy those solar panels? And so one of the things I did want to cover here was orbital maneuvers. We've already seen a few in action here. We have prograde, for instance. That we want to get around to matching. We're at 73 right now. I think that's a fine orbit, or it will be a fine orbit as long as I spread this out a little bit. There we go. That is okay for now. That is better. Now we can point target here. I'm going to turn on stability assist afterwards. And we'll just time warp through this little period here. Ideally, we want to make this orbital insertion burn as low as possible. So if you have extra fuel in your stages, instead of carrying them up with you and creating space debris, which will become a bit of an issue, rather, if you're not careful. You could do what I did and expend all the fuel, although you have to be really careful with that. There we go. Okay, just a little bit more. We'll do it. I'm happy with that. So, let's say we wanted to go to the moon. No, we're not, but one of the things we want to do with it is line up with it. And you see we have 0.3 degrees of inclination here. Well, how do we solve that? One thing we can do is we can simply, if we look at the fact that we're at our ascending node, we want to go the opposite direction. So we can burn anti-normal in order to do that. You can see that our orbit has changed just a little bit. But by going anti-normal, we have burned in the proper direction. It's more efficient if we burn, for instance, directly at the node. So in this case, we want to burn normal because we're at the descending node now. You can see now we have virtually no inclination. If you want it to be perfect, which it doesn't usually need to be, then you want to burn, I guess, until it says NaN, which means not a number. So there we go. Let's say now we want to increase our orbit. Well, we remember this from last time. We have plenty of fuel in back, so let's do it. We can burn, we can burn prograde. And I'm just gonna go out for, I don't know, I'm gonna burn 400 meters per second. I know this vessel has a lot more than 400 meters per second, but just for the purposes of demonstration, I want to go ahead and do that. So let's get to that node. And there's really two things we can do here. I mean, you can see right now we're at the radial point here, and you can see our target is about to line up with prograde. Now we have 45 seconds in which we want to perform this burn, so again, divide that by 2. And the reason you do that is simply because of the fact that if you don't divide by 2, then you'll overshoot just a little bit. So in this case, we want somewhere around 22 seconds to begin our burn. And that will happen very, very shortly. I'm just going to hit Z here when that does. It doesn't have to be perfect, of course. It's one thing, to, I guess, perfect is very difficult, and there's some cases where the, let's get that down here just a little bit. So we have passed our burn point just a small amount. The thing I was going to say too is that there's a feature we haven't used here yet. let's say we're at our ascending node right now, and we want to do some fine tuning to where this is not a number. Well, we can do that. And we can do something relatively close to it anyhow. That is the ascending node. So we can point downward here. But we don't want to use any fuel. That's the tricky part, or we don't want to use much fuel, and we don't want to get ourselves too far off course. Well, if we hit R, and I can hit H, and that will lower us just a little bit. And you can see here, it is quite sensitive, partially because of our orbit. Now, what do you reckon would happen if we burned towards the planet? Like so. We could do that with the burning towards the planet in this case is our radial or anti-radial vector. Do you think that we will actually make it to the surface, or maybe would something else happen? Well, let's see. As you can see, by burning towards the planet, it actually raises our periapsis. And to some extent, it raises our apoapsis as well. And so this imparts more energy into the system. Likewise, if we burn anti-radial, or we were just anti-radial, but if we burn radial, it'll have the opposite effect, to where it will increase our apoapsis to a certain point, but it will lower our periapsis as well. And so when you're burning radial, it rotates your craft. And that's something that's important to think about. Now, what if we wanted to make this circular? Well, that might be kind of difficult, actually, because we used a lot of our fuel in those rotation burns. Those rotation burns, as it turns out, are not cheap. But we could raise our periapsis in two ways. We could burn radial, which we know is expensive, or we could also burn retrograde, or prograde, at apoapsis. And because of the Oberth effect, this is the best place to do it. So you can see here now that by pressing R and pushing H, we are very slightly raising our apses. You can definitely use these as engines, although I want to hold prograde here. We can also burn all this up as well, and that'll raise our apsis. What if we want to go the opposite way? What if we want to go towards the planet? Well, again, burning retrograde is a bad idea. So what we want to do instead, or burning prograde is a bad idea because it'll increase our orbit, and burning radial is a bad idea because it takes a lot of fuel. But we could take this guy here and lower it just a little bit. Now, we still have some things we need to do. We're seemingly out of fuel, except we're not. You see, we now have this guy right here. We have our RCS, and it's very important to remember that if you have RCS on your vessel, and as long as you have RCS ports, it is a trivial matter to, well, maybe it's not trivial, but it's not such a big deal, because you can use your RCS to get out of that situation. And failing that, you can even do this. You can do something you wouldn't think you would be able to do, which is getting out and pushing. So I'm going to hit R here. Let's just assume that we are completely out of fuel. But what we can do here is we can get close to this guy, somewhere where we would have the ability to push. Maybe like this parachute, for instance. And we can treat this just like the RCS ports. So I'm going to push H here, and for some reason, right. Well, in this case, you're in docking mode when you're in EVA mode, so you actually want to push W. And if you're in a really bad situation, you can send this guy out and get him to push your vessel, and then when you go back in, you can, there we go, you can do other things. Now, before we do go back in, what are the controls on this? Well, you're using something called docking mode here, which means that W is forward and S is backwards, and A and D strafe left and right. What about vertical movement? Well, you can use shift and control there, although I wouldn't recommend doing that on your ship. Another thing about EVAs is that, let's even see if we have much of an effect. I bet we did. Yeah, we're actually, we pushed prograde, of course, so we raised our apsis a little bit. You do probably want to push the direction the engine's facing if you're facing retrograde. But really, two things I want to show you here. Orientation does matter just a little bit here. First of all, I want you to observe that when we come back out of the capsule, our EVA fuel is refilled. This was originally supposed to come out of your monopropellant supply, but for some reason, that is not the case. However, I guess the KSP people decide against it. However, there is something I want you to know about, and this actually happened to me during a recording session, to where this may not be as hard to get onto because it's at an angle, but I'm just going to try real quick to get out of it. Definitely orientation can be very confusing with this if you're not paying attention. But on top of that, you have this hatch at the bottom now. And there's reasons why this presents a problem, because you could see that we can control our direction with the mouse. But actually getting into this sky, once we, get up to it. And this can be a bit of a problem here as well, because you can't really see what you're doing. But let's say I do this. Sometimes you will get knocked off the spacecraft, and the Kerbal will do things like backflips off of it, like that. If you ever find yourself in such a situation, you may in vain attempt to do this, not realizing that there's no way to angle the camera correctly. So what do? Well, you can get yourself into free mode in order to do that. You could do that by hitting V. And now this guy is about where he needs to be for us to get onto the spaceship. So, let's ride out to re-entry. In this case, we have no chance of saving this pod, so I'm going to do myself a little bit of a trick. This decoupler, if we want to lower our altitude, it does have some force on it. So if we stage here, you'll notice that we went down from 39 to 36. That guy will burn up into the burn up in the atmosphere rather. But in the interim, we should be pointing prograde, I believe, would be the best way to point. Or retrograde. So that the bottom of that engine is pointing where it needs to be pointing. Although it seems not to be doing such a good job. That is not quite retrograde. I found that these guys are somewhat inaccurate sometimes in the way that they calculate these things. But I'm just going to do this. We'll get into the atmosphere and Jeb will land. And hopefully we will continue to descend without problems. In fact, if we turn this off, we should eventually, even though we're rocking a little bit, we should eventually hit retrograde. Oh, there are other things too. I guess I did not mention that, WSA and D happen to orient the rocket in terms of its cardinal direction, or not of cardinal directions, but of the two radial directions on the nav ball. But there's also Q and W which rotate you. And that could be very useful for you as well. Now, because of drag, we are having issues with rotation here. But if you did this in space, or if I did this without the fine control on, then that actually looks a little bit dangerous. It looks like we're about to throw off our parachute. But this can be useful for a number of things. Mainly if you're building a space station and you want to orient your space station in a certain direction. But I think that'll do it for now. Hopefully you learned a little bit about rocket construction and maneuvers in orbit. And until then, this has been Nilord Brute, and I will see you later.